the historical answer has always been smaller is better. And that's true in the PTA world because, for one, any interventional type of catheter, you want the penetration into the patient to be as small as possible. So I always use the example of balloon technology. To make a 50 atmosphere balloon is simple. If you don't care how thick the walls are and how large of a hole you need to put into the patient. But if you're wanting to do it with a 6 French or a 5 French introducer sheath, wall thickness is critical. So there's always that balance between pressure and wall thickness, or the ability for the device to pass through a small opening. So it's patient comfort and it's trackability, as you mentioned, to reach places in the anatomy that are quite tortuous to get to, especially the smaller ones that Chris mentioned earlier up in the brain.
Yes. Yeah, I think that's where we're finding a lot of value here with customers, especially over the last couple of years, where R&D engineers in a lab setting, have cobbled together a multi-layer composite construction, and the output leaves a balloon that could be compromised in performance, maybe a folded profile that is less than ideal from an introducer perspective or a trackability perspective. And then we'll take that initial concept, apply our DFM expertise that we've developed over 20 plus years of these composite balloon layer constructions, and recommend any sort of design or process tweaks that are necessary that make the balloon more manufacturable, or the system overall really, more manufacturable, higher quality, more dependable, that'll pass the rigorous validation efforts that it takes to commercialize a product.
That's a good point. It's one thing to be able to develop a miniature part, balloon, catheter component, but the ability to handle it, maybe automate it, scale it, and validate it takes a little bit more grit.
Exactly, and that's where we believe we're differentiated. We have the expertise on the balloon side, but from day one on balloon design, we're thinking of how that balloon's going to interface with the system, and we understand that as well. And then, what it will take to pass the dimensional and performance specifications of the balloon. And we've got a large library of test methods, and that's where those years of different application experiences across different markets and different indications of use really add a lot of value to our engineers.
Okay, excellent.